Chapter 1 Networking Concepts. What is computer network? When a number of computers are connected in order to communicate or share information, they form a network, and this is defined as a computer network. Internet is an example of a computer network. The purpose of computer networking is to build communication between computers. This communication includes exchange of data and information with the help of software applications installed in computer systems. A computer network can be formed between two or more computers linked together in a room or a building, a town, a city, and across the globe. A computer network can also include peripheral devices such as printer, scanner, and so on. The computers or devices within a network that originate, route, and terminate the data are called nodes. The computers in a network can work independently and communicate with each other too. Hosts, such as personal computers, mobile phones, servers, and networking hardware are different types of nodes. The computers are interconnected through different media, such as cables, telephone lines, radio waves, or infrared light beams. Every network has a control center, which allows the different nodes to communicate. A network can be of two types. Intranet, it refers to a network that is private to an organization. Internet, this network is open to all. Anyone can connect to it. Advantages of networking. There are many advantages of computer networking. Some of them are given below. Cost-effective. Besides software, hardware devices such as printer, scanner, and modem can be shared by all the computers on a network. Thus, it saves a good amount of money by eliminating the need of buying additional hardware and software for each computer in a network. Backup. Suppose a computer in a network faces some technical issues or hardware failure. In this case, the work can be allocated to another computer in the same network. Networking helps to look for lost data at one place. Communication tool. It is a convenient mode of communication for any organization that has branches at different locations. Easy access to remote database. One can instantly book railway or airline tickets from anywhere. Hence, it saves time and effort. Accelerates efficiency. It allows the upgradation of software and data from a single point, thus enhancing the efficiency of a working system. Reduces the need of hard copies. There are times when a copy of some document is to be circulated among the members of an organization. In such a scenario, a soft copy of the document can be shared among the members over the network. Real-time delivery. One can instantly share data and information across the globe. Types of networks. The computer network can be classified into various categories based on the coverage of geographical areas. The various categories are discussed below. Personal Area Network (PAN). A PAN allows communication among devices such as personal computer, mobile phone, digital camera, personal digital assistant, PDA, tablet, and so on. This kind of network covers a small area of nearly 10 meters. It is widely used to transfer files such as emails, images, audio, and video files between devices. PAN can be easily set up between two devices. It is built using USB cable, wired media, or Bluetooth, wireless media. Local Area Network (LAN). In LAN, two or more computers and peripheral devices are connected within a room, building, or a small campus. LAN covers the area of a few kilometers and usually links the devices in that area with wires or Wi-Fi. LAN is owned and controlled by a single person or an organization. Therefore, it is private in nature. An office building or a compound of an institution usually contains a single LAN. Metropolitan Area Network (MAN). As the name suggests, MAN is a larger network than LAN and connects computing devices which are located at geographically separated areas within the same city. MAN covers an area of a few hundred kilometers in a city. MAN allows high-speed network sharing of resources for a group of institutions, organizations and branches of banks that function within the same city, and so on. Wide Area Network (WAN). A WAN connects two or more computers located at distant locations. They are interconnected through telecommunication or satellite signals. The use of WAN is majorly restricted to large establishments and government agencies that are spread across a country, continent, or even across the globe. It uses public telecommunication media to transfer data. ATMs, customer services of national and multinational banks rely heavily on WAN to transfer data. Network components. To set up wired networking in a group of computers for data sharing, some additional components, such as interface cards and other equipment, are required. The hardware components that are required for establishing wired networking are given below. Network Interface Card (NIC). This card provides an interconnection between the network and the computers or nodes. Most computer motherboards usually have an inbuilt network interface card. It is used to connect a computer to a network for enabling participation in network communication. Network cable. Registered Jack 45, RJ45, is an 8-wire network cable. It is a connector which is commonly used to link the network interface card (NIC) with a hub. It is also used to connect and transfer data and information between computers and switch. Hub. It is a network device which connects computers and computing devices to exchange data between them. Each hub has some ports which determine the number of devices that can be connected to it. For example, 6, 8, 12, 24, and so on. A hub can also be linked to NIC through RJ45 cable. It primarily broadcasts the message, which increases data traffic over the network. The information is received by the intended computers and automatically rejected by other computers over the network. Switch. The function of a switch is similar to that of a hub, but it is more intelligent as compared to hub. It not only checks data packets as they arrive, but also determines the source and destination of each packet before sharing them. Switches are preferred over hubs due to their efficiency. In addition, a switch prevents data collision and reduces network congestion, thereby increasing the network performance. Network architecture. Network architecture refers to the overall framework of an organization's computer network. To establish network communication, it is important to have a detailed view of all the accessible resources in it. Network architecture includes the following: hardware components used for communication, topology, wired or wireless connection, protocols. There are two types of network architecture. They are listed below. Peer-to-peer. This type of network architecture is suitable for a small environment, usually having up to 10 computers. Each computer connected over the network has equal capability. These computers must have specific rights to use or share the available resources. In peer-to-peer network, there is no dedicated network administrator or central server. This means each computer can act as a server as well as a client. This network is easy to set up and is less expensive. Client server. It is a network in which several computers called clients are connected to the main computer called the server. A server in a network is a computer that controls all the connected computers, shared devices, and other resources. Clients are computers that request services, such as data retrieval and storage from the server. In this network, if the server is turned off, its resources on the network are not available. Transmission media. Transmission media means the physical material that is used to transmit data between computers. Transmission media can be classified into the following categories: transmission media, wired transmission media, wireless transmission media, wired transmission media. This type of transmission includes cables or wires to transmit information from source to destination. The wire may be made up of copper, any other metal or glass fiber. It includes electrical and light signals to flow in these wires. These cables are very sensitive to noise, and this degrades the signal, which is also called attenuation. There are various types of cables that can be used for setting up a network. Some of them are as follows. Twisted pair cable. Twisted pair cables were invented by Alexander Graham Bell in 1881. It is the most widely used medium for telecommunication and consists of copper wires that are twisted into pairs. Ordinary telephone wires consist of two insulated copper wires twisted into pairs. Computer networking cables consist of 4 pairs of copper cabling that can be utilized for both voice and data transmission. Twisted pair cables are of two types: shielded twisted pair (STP) and unshielded twisted pair (UTP). UTP cable is the most commonly used cable in computer networking. Coaxial cable. Coaxial cable was invented by an English engineer and mathematician, Oliver Heaviside, in 1880. The cable consists of a copper or aluminium wire wrapped with an insulating layer of a flexible material. The insulating layer is surrounded by a conductive layer called shield, which is finally covered with a thin insulating layer on the outside. Fiber optic cable. Optical fiber cable. The optical fiber cable consists of a central glass core surrounded by several layers of protective materials. Optical fiber cable has the ability to transmit signals over much longer distances than those covered by coaxial and twisted pair. It also has the capability to carry information at very high speed. This capacity broadens the communication possibilities to include services such as video conferencing, etc. Wireless transmission media. The transmission in such a media is wireless. It is used to provide wireless network communication over short distances using radio or infrared signals instead of network cabling. Some of the wireless transmission media are as follows. Radio wave transmission. Radio waves transmit music, conversations, pictures and data invisibly through the air, often over millions of miles. Radio waves travel in all directions from the source, so that the transmitter and the receiver do not have to be carefully aligned physically. These are easy to generate, can travel long distances, and penetrate through buildings easily. The two common technologies that use radio frequency waves to create a network are Bluetooth and Wi-Fi. Bluetooth wireless technology. Bluetooth is a wireless technology that lets you talk and share information like voice, music and videos. Bluetooth technology was invented in 1994 by engineers at Ericsson, a Swedish company. It is built into electronic gadgets. Mobile phone, FM radio and television all use different kinds of radio waves to send information such as audio and videos without using wires. Bluetooth technology also uses radio waves. The biggest difference between Bluetooth technology and devices like FM radio and TV is distance. Radios and TVs are meant to broadcast information to many people over miles or kilometers. Bluetooth technology sends information within its personal space, which is called PAN. The maximum data transmission range of Bluetooth technology is 10 meters, 33 feet. A product with Bluetooth means it has a piece of hardware as well as software to connect that product with other products wirelessly using the Bluetooth technology. B. Wi-Fi. Wi-Fi stands for Wireless Fidelity. It is the name of a popular wireless networking technology that uses radio waves to provide wireless high-speed internet and network connections. Wi-Fi networks use radio technologies to provide secure, reliable, and fast wireless connectivity. Infrared technology. Infrared technology is used to send documents from portable computers to printers, to connect home entertainment systems, and to exchange information between computers, cellular telephones, and faxes. The communication range of the devices communicating through infrared waves is very limited. These waves cannot penetrate walls or other obstructions, so there should be no physical barrier between the communicating devices. A television and a remote control are connected through infrared waves. Microwave transmission. For long-distance communication, microwave radio transmission is widely used as an alternative to coaxial cable. The main advantage of the microwave transmission is that building a tower is cheaper than laying cable. Microwaves can pass through the Earth's atmosphere easily and can be used to transmit information between satellites and the Earth's base station. Network topology. It is necessary that the computers that are to be connected must have access to the same network sharing resources. Let us learn how a network is created. To understand this, first you need to know about its topology. Network topology refers to the schematic description of the various components of a network, such as nodes, links, peripherals, and so on. It determines how data flows within a network, irrespective of its physical structure. The most commonly known network topologies are given below. Point-to-point, PTP, topology. It is the simplest and the most conventional model of topology. In this topology, two nodes are directly linked to each other. For example, a computer system is directly connected to a printer. In this network, a dedicated link is formed between two devices, that is, the sender and the receiver. It is faster and more reliable, for there is a direct connection between the devices. This network can only be used for small areas where computers are in close proximity. Bus topology. In this type of topology, all the devices are connected to a linear cable called bus or trunk. The bus acts as a backbone of this network. This topology is the simplest way to connect multiple devices. It uses cables for connections. This network is easy and inexpensive to implement for small networks. In this topology, one of the computers in the network acts as a server and provides data to all the clients. The advantage of this network is that if one computer system breaks down, it does not affect the other systems over the network. However, if the main cable fails, the entire network becomes unusable. Ring topology. In this topology, all the nodes in a network are connected to one another in the form of a ring. Each node is linked to two other nodes, forming a single continuous pathway for signals. In this network, data travels in a circular manner. Ring-shaped networks offer high bandwidth and can span large distances. This topology is losing its popularity because it offers only unidirectional data flow. Like bus topology, in ring topology too, addition and removal of systems could cause network disruption. Moreover, a single break in the connection could disrupt the entire network. Star topology. In this type of structure, all the devices are connected to a central device which acts as a hub or switch. Each device is linked to the central hub through a separate connection, and thus it requires more connections. But the benefit of using separate connections is that if there is a connection failure, it would affect only the functioning of a single system on the network. Unlike the bus and ring topologies, no disruption is caused at the time of addition or removal of a system from the network. Here, all the information or data first goes to the central device, that is, a hub or switch, and then to the respective systems. Therefore, a hub or switch controls the network communication. Since all the data passes through the central device, it increases the threat of a single point failure, which means that if the hub or central device fails, then the entire network goes down. Tree topology. A tree topology connects a star network to another star network. Thus, tree topology is formed with a group of star networks connected to a bus. Therefore, this topology is also called star-bus topology. In this topology, if the main cable that connects to star topology networks fails, then those two networks would not be able to communicate with each other. However, the systems on individual star topology would still be able to communicate internally. In tree topology, the expansion of network is easy. However, the maintenance becomes difficult. Mesh topology. In this topology, each node has a point-to-point link with each other. A single computer does not act as a server. In this network, every node not only sends its own signals, but also relays data from other nodes. This network is also known as meshnet. It provides data security and privacy since data is transmitted through dedicated channels. It can also manage high data traffic. Network security. It is important to secure data and resources from unauthorized access and misuse. Therefore, it is advisable to protect your data and secure the network. The purpose of network security is to secure information of an individual or organization, and also to protect the computers on a network from any attack. There are various methods to keep your network secure. Some of them are as follows. Access control. It is used to block unauthorized users. Application security. It always protects the applications stored in a computer system. Data loss prevention. There is always a fear that any member of the organization may send or upload sensitive information outside the network. This can be stopped by data loss prevention (DLP) technologies. Firewall. Firewall is a security system that protects a computer from unauthorized access over a network. A firewall can be implemented using hardware or software, or a combination of both. Firewall follows a set of rules that determines which data can enter and leave a network.